Good morning, class. Today we are going to learn classification of materials. Okay, so the basis will be resistivity and the dependence of temperature. Okay, so on the basis of resistivity and its dependence on temperature, materials are classified into three parts. Actually, four parts, but in this class we're gonna learn only three parts. Okay, so on the basis of resistivity, materials are divided into three parts: conductor, next insulator, or say semiconductor, next is insulator, and the last we want going to study about the last one, that is superconductor. Okay, so now in conductor we will study about metals, or in conductor there are metals and alloy. We will be studying metallic alloy. In case of semiconductor, graphite, silicon, and germanium. Okay. In case of insulator, we will study paper. There are paper, wood, glass, etc. Okay. In case of superconductors, they are actually combination of two or more elements. Okay. So we are not going to study superconductor. Now, in conductor, what is the basic feature of conductor? Conductors, actually the materials, they have large number of free electrons. That's why the conductors are good conductor of electricity. Okay. So why? Because conductor have large number of free electrons. Have large number of free electrons. Okay. In case of semiconductors, they have few number of electrons. That is free electrons. Have few number of free electrons. Okay. Now for insulator, they have practically no free electrons. Have practically no free electrons. Superconductors, they are different from conductor, semiconductor and insulator. Okay. For superconductor, resistivity, or we can say resistance, is almost zero. Resistance is equal to 0. Okay. The superconductor offers zero resistance to the flow of electric current, but there is some condition which should be imposed on or upon compounds to make it superconductor, that is lowering the temperature. To have superconductor, to to have superconductivity, the temperature should be below a fixed temperature, a certain temperature, below a certain temperature called critical temperature. Below this temperature, the compound will behave as a superconductor. Okay, so this is the condition to have superconductor. Now, for conductor, they offer low resistance. Okay, offers low resistance. What is the range? The range of resistance for conductor are resistivity. It is 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter. Okay, so this is the resistivity range for conductor. Okay, conductor, that is metals and alloy. The resistivity of metal and alloy lies between this range. Okay, so now for semiconductor, they offer resistance which lies between insulator and conductor. So whenever temperature increases for semiconductor, the free electrons generation or numbers of free electrons increases due to breaking of covalent bonds. Okay, so in case of semiconductor, if you increase the temperature, then number of free electrons increases. That's why when temperature increases for semiconductor, then conductivity of semiconductor increases. Okay, if temperature, later on we will discuss this. Okay, so first let us know the range of resistivity. Okay, for semiconductor, they offer resistance. Okay, but their resistance almost depends on temperature. Not only for semiconductor, resistance of conductor also depends on temperature. Okay, resistance of conductivity also depends on conductor. So now, range of resistance or resistivity, it is 10 to the power minus 5 to 10 to the power 2 ohm meter. Okay, so now for insulator, we know insulator, they have practically no free electrons. Okay, so if you consider insulator, then almost the current will not pass through insulator, or insulator will not allow, or they won't allow the electricity to pass through them. So the resistivity range is 10 to the power 10 ohm meter to 10 to the power 17 ohm meter. Okay, this range may fluctuate depending upon the book. Okay, so this is in some book you can also find some variation in the range, so no problem. Okay, so now superconductor, their resistivity is very very low. Okay, below certain temperature the resistivity almost vanishes, so they are superconductor. Okay, so now see the temperature differ, how the temperature alters or temperature affects the conductivity, or we can say resistivity of a conductor. So whenever you increase the temperature, and for conductor the resistance increases. Okay, if temperature increases, then resistance also increases. In case of semiconductor, when temperature increases, then resistivity or resistance or resistivity decreases. Why? Because in case of semiconductor, when we increase the temperature, then covalent bond breaks and it releases large number of free electrons due to breaking of covalent bond releases free electron. Okay, this is the point you should remember. Now for insulator, the resistance is infinite. Okay, so almost we do not depend on temperature. Now for superconductor, the resistivity depends on temperature. How? Whenever you decrease the temperature below a certain value of temperature, that is critical temperature, this is critical temperature. Okay, then this superconductor means the material behaves as a superconductor. Okay, to have superconductor we have to decrease the temperature below certain limit, that is critical temperature. Then below critical temperature the compound or the material will behave as a superconductor. Okay, clear? So now next, okay, you can note it down. Okay, so materials are divided into four parts. Four categories: conductor, semiconductor, insulator, superconductor. Conductors, they have large number of free electrons. Semiconductor have few number of free electrons. Insulator, practically they have no free electrons. Superconductors are the compounds when temperature are lowered below a critical temperature, then the compound behaves as superconductor. They have zero resistance at certain temperature. Okay, so conductor offer low resistance, they offer some resistance, but their resistance depends on temperature. How? Temperature, when temperature increases, their resistivity decreases. For conductor, temperature increases, resistivity increases. But for insulator, temperature do not affect the resistance, it remains same. For superconductor, obviously the temperature depends on resistivity. Okay, below critical temperature compound will behave as superconductor. Okay, so these are some materials we generally see in our daily life. First is tungsten. Tungsten is a material, its melting point is very high. Okay, melting point is very high. Melting point is very high. Okay, that's why tungsten is used to make bulb filaments. Okay, so now next is tungsten. Tungsten is used in bulb filament because its melting point is very high. That's why whenever the temperature of the filament is very high, at that time also the filament do not break. Okay. So now next is constantine. Constantines, these are alloys actually. This is alloy actually used to make resistance wire. Okay. If you go to your physics lab, you will find different kinds of wire. Generally, the wire which is used for special purpose, it is for resistance in circuit. That wires are made up of constantine. Now next is manganese. Manganese, alloy of copper and manganese. Okay, used to make resistance wire in case of rheostat. Whenever you visit a physics lab, you will see a device called rheostat. In rheostat, there is a wire which is formed in shape of coil. Okay, that coil is a wire actually made up of manganese. Now next is nichrome wire. You have seen electric heaters. Okay, if I am not wrong, every household generally uses electric heater. Okay, so that electric heating coil is made up of nichrome wire. And what is nichrome wire? It is the alloy of nickel, chromium, manganese and iron. So it is used to produce large amount of heat. The resistance of nichrome is almost higher, okay, but the special property of nichrome wire is that at high temperature it do not easily oxidizes. Okay, it do not easily oxidizes. Okay, that's why oxidizes. That's why it is used to make heating coil. Now our last useful material is lead tin alloy. This lead tin alloy is used to make fuse wire. Whenever we are using fuse wire, the material of the fuse wire is lead tin alloy.